Welcome back again for advanced functions. This is polynomial equations and inequalities unit. In this lesson number 2, we are going to figure out ways of solving linear inequalities. So first, let's get comfortable with using an interval notation. So first of all, when you have a round parenthesis, like a bracket, it means that x is greater than a, but less than b. So it's not including. But when you have a square bracket, that means x is greater than a or equal to, and it's less or equal to b. Okay. Again, you can mix up the round bracket or the square bracket. So in this case, you can write it in set notation like this. So what that means is that x is greater than a and is less than or equal to b. So you just be mindful about if you have a square bracket, it's including that number. The next one is when you have an infinity sign, whether it be positive or negative infinity, you cannot use a square bracket because infinity goes forever, so you don't know where it's going to end. So therefore, we always use a round bracket. So in this case, we say x is greater than a, or x is less than or equal to a. So keep in mind here that you could use a square bracket, meaning including that number, but you cannot be including any infinity or negative infinity. So complete the following table. So we're given 4 different categories. So we're given inequality notation, and we are also given the set notation, interval notation, and you should be able to graph the solution. So let's get started with the first one. So it's -2 in between, so it's x is greater than -2 or less than +3. But keep in mind that it's including -2 here. So therefore, for interval notation, x is a set of any real number such that it's greater than or equal to -2, but less than 3. So it's exactly the same thing, but for solution set notation, you have to include that x is any real number. Now for interval notation, so it's including, so -2, and it's excluding up to 3. So I label -2 as a closed circle, it's a point, and for 3, it's an open circle, it's a hole, because it's not including 3. And it's going to be in between, so I color anything between -2 and 3. Okay. Next, we have solution set x is less than or equal to -3. So we write everything exactly as it is, but excluding that any real number. And so that means that the number is it could be very small, negative infinity. So negative infinity, comma, and -3, and because it's including -3, it's a square bracket. So at -3, including, and it's going to be going down. It's going to decrease with the arrow going forward. Okay. Next, now we are given an interval notation this time. Okay, so it's in between -4. Oh, but it's going to get bigger because it's positive infinity. So that means x is greater than -4. So in this case, x can be any real number such that x is greater than -4. Same thing. So at -4, which is a hole, and it's going to be colored in with the arrow, like this. Okay, so it's going to get positively bigger than -4. Now, inequality. So some of the symbols that you have to know, this is less than, this is less than or equal to, other way around is greater than or equal to, and if it's not equal to, then you use this equal sign with the strike. And keep in mind the solution is a set of any real number as long as the inequality is going to make the statement true. So let's try solving inequality here. So first thing you have to do is make sure that we want to find all the x variables. So let's simplify by doing the distributive property. So you don't want to have any brackets here. So it's going to be 2 minus 3x plus 3 greater than or equal to 6 minus 2x minus 4. So you want to expand the brackets, and now we are going to isolate the variable, so collect the like terms. So I'm going to bring x's to the left side and numbers to the right side. So negative 3x plus 2x greater than, so 6 minus 4 minus 2 minus 3. Okay, so let's simplify. So this is negative x greater than or equal to negative 3. Now, so we want to isolate for x, and there's negative 1. So every time you divide or multiply by negative 1, so I'm going to multiply by negative 1 to both sides, then it's going to flip. The inequality sign is going to flip this way. So negative x divided by negative x, it's going to become positive. Negative 3 divided by negative 3, it's going to be 3. Okay, so always keep that in mind when you're multiplying or dividing by negative 1. For inequality, you have to switch the sign. So this is my final answer. And if we have to graph it, so it's at 3, so it's a closed circle. And this is for x. In this case, so x is smaller than or equal to 3, so closed circle, and with the arrow going this way. And that is your final answer. Now, what if you were to have a double inequality? So double inequality means that you may have a variable both on the left side and on the right side. So let's see. So this could be separated with x is greater than a, or x is less than or equal to b. So you can separate it when you have a double inequality with a variable on both sides. So number 3. So it says solve inequality and graph the solution. Again, let's expand. So 4 greater than 2x plus 6, then 0. So now I'm going to divide it, both sections. So I'm going to put positive 6 on the other two sides. So what that means is that I'm going to neutralize it by doing minus 6 here and minus 6 here. Or let's put it this way, minus 6 here. So I'm bringing this to this side and this side. So therefore, so it's going to be 4 minus 6, which is going to be negative 2. And then 2x, negative 6. Now I'm going to divide both sides by 2. So it's negative 1 greater than x greater than negative 3. If I have to draw a number line, we have negative 3 and negative 1. So x is greater than negative 3, but less than negative 1. So it's excluding, so it's an open circle and this way. So anything it's in between. So if you want to write it small to big, so I would rewrite it as a negative 3, x is greater than, and negative 1. So that would be the most ideal way of representing inequality from small to big number. Okay, next question. Solve inequality. Again, this is a double inequality because it looks like we have x on the left side and on the right side. So first thing, you gotta divide it into two sections. So if that's the case, so x is smaller than x plus 1, and we have x plus 1 smaller than x minus 2. Okay, so I'm going to move x to the one side this way. So x minus x, 1. So 0 is less than or equal to 1. And we have, let's move this to the other side. So this x and x cancels out. And I'm going to move negative 2 to the other side. So it's positive 2. So 3 is greater than or equal to 0. Now, well, let's see. So yes, 1 is definitely greater than or greater than 0, okay? But it's not equal to 0. So there are some false information, and this is also definitely not true. 0 is not greater than 3. So it is true in a sense that 1 is greater than 1, but definitely this is false. And the x cancels out. So therefore, if that's the case, there is no solution. So you can represent it using a set notation where x belonging to this one. So this means it's an empty set, showing that there are no solution to this.